Hey fellow developers, my name is Christoph Limpelaer, and I'm the host of Scale Your Code. This is a show where I ask some of the best developers technical questions so we can learn from their thought process and apply it to our own careers. Today's developer is known by many for his technical chops and strong viewpoints. David, welcome to Scale Your Code.
Thanks for having me.
Well, it's a pleasure to have you here. So before we get started, I really want to personally thank you because there was a point in time when I was trying to figure out what to do with my life because I just didn't feel like I fit in any single industry. And somehow I ran across your book called Rework and just started reading it. I don't even know if this was your intention with the book or not, but it made me realize that we can go against the status quo and it's okay. We don't have to go the same route that everyone else is going. And we can listen to our own thoughts that tell us that there is another way instead of just suppressing them because it doesn't fit in some category that society tells us to fit into. And this has just really changed my outlook on many things in life. And really for that, I can't thank you enough, or even Jason, since you both wrote the book together. And it's also a big part of the reason that I wanted to get you on the show because I want to get this outlook that you have on approaching projects and business and to see how you've made it or how you've taken it and applied it to Basecamp, for example, and scaled it to quite a massive size and also to very fast speeds, right? This is a very rapid application. So to get started, can you give us a sense of the scale at which you're running, like the number of users, how much data you have, that sort of thing?
Sure. Well, first of all, I'd say that I think the contribution that Rework made to a lot of people is exactly as you're talking about, that they recognized that the thoughts that they had were not sort of that outlandish, that other people were thinking the same things. They just weren't hearing that from other people.
Exactly.
So the biggest fans of Rework have generally been people writing us and say, I thought that too. I just thought I was the only person in the world who thought that way. So it's really great to get people together and realize that they're not alone in pushing back and questioning the status quo. But anyway, to get to your question, the sense of scale we're running at Basecamp. So in terms of user numbers, the one we've been sort of throwing around out there is not that actionable because one of the advantages you can say of being a private company is picking and choosing which numbers you want to share. So the number we have shared is that more than 15 million people have used Basecamp. But what does that actually mean for scale? It doesn't actually mean that much for scale. Some of the technical aspects of it is far more interesting. I was actually just looking into this data this morning and somewhat surprised to learn the scale that we're currently at. So at the moment, we're currently at about 2,000 requests a second against a Rails app instance at peak. So that to me is a lot. I mean, we obviously started at a completely different base back in the day, 12 years ago. So to be at 2,000 requests a second is quite something. Even though, I mean, it's still a tiny number. Toby from Shopify tweeted me back and said something like, Shopify is right now doing 17,000 requests a second against their Rails app instances at peak. And I'm sure there are plenty of others who are doing even more than that. But I think the number still represents an interesting data point in the sense of where Rails came from and what the earlier position looked like. The earlier position was very much about, well, but does it scale? Can you run an application of that size where you have hundreds of thousands of people using your application all the time? And the answer, obviously, through these numbers, through Toby's numbers, through the numbers of plenty of others, is a resounding yes.
Yeah, obviously that was wrong, yeah.
Yeah, I mean, that was just one of those opposition points that just did not pan out. And of course, we were saying that at the time, but we didn't have the numbers to back it up. Now, we're more than a decade into Rails, and some of those early Rails applications have gotten to the point where the numbers are all there.
Also, when Twitter was running into some issues and some people were blaming that on Rails, you also have to look at how it's being used, right? Rails is not going to be used for every single part of your application. Some things are not going to work quite well. So you also have to look at that perspective as well.
Absolutely. And I'd say the number one determining factor as to whether your apps will scale or not scale is the algorithms and the architecture you're using. So there are all sorts of ways to go wrong where you can have the fastest programming language in the world running on the fastest database server in the world.
Yeah.
If your setup, your architecture, and your algorithms are wrong,
Mhm.
well, it's not going to scale anyway. And it
Right.
will get beaten by the slowest programming language in the world, running on the slowest database server in the world. Um,
Yeah.
in terms of the data, though, I mean, we have the sort of peak use of Flow with the 2,000 requests a second. On top of that, we have about, I think we're storing something like 700 terabytes of user uploads on a distributed cluster of clever safe installations,
Mhm.
and on top of that, we have about what is it, 1.5 gigabytes. No, wait, what was it? Trying to remember what the size of our
Well, I saw a talk.
1.5 terabytes is the database size.
Okay. I actually saw a talk from John Williams, who was on your team, and I think it was a pretty recent talk, so I feel like these stats are pretty accurate, where he said, like you said, about 1 terabyte in a single MySQL instance and about 375 gigabytes in a single MySQL table.
Right.
So, yeah, I feel like that was
I
recent.
think what's interesting with those numbers too is that the scaling of those numbers have come from a very sort of unsophisticated place. We still run a single write database for all the applications.
Hmm.
We have not gone to multiple writing on any of them. We do have read slaves that we use for a couple of them.
Sure.
Actually, I don't even like this terminology. We've recently started picking up on the terminology of using primary and replica, so I'll use that going forward. For the primary database, that all the writes are just going to a primary. We're experimenting with some other sort of live setups now with some primary
Mhm.
setups, but those are not for performance. They're more for resilience and cross data center sort of setups.
So why don't you? Why is it? Why do you call it primary and secondary instead of master and slave?
I think there's a good discussion going on in the technical community right now about language matters, and there's a lot of baggage rolled
Hmm.
up into the language of master slave that's just unnecessary.
Sure.
And I think there are better terms that even more accurately describe the kind of setups that we have that also don't carry all that baggage. So we made a point a while back to say internally at Basecamp, hey, let's just use language that's both more accurate and doesn't have that cultural baggage.
Hmm.
Because why would we be stuck to that just because that's always what we've done, right? Like the whole point of changing things for the better is that you examine the ways that you've always done things and consider whether that's still the best way going forward. And we just thought, hey, this just makes sense, so let's change it.
And that's exactly what rework is about as well. So you mentioned Shopify, which I actually interviewed Simon Eskelson just a few weeks back. Uploaded that video about 2 weeks ago, maybe. So if you're interested in learning how they've scaled that, then definitely check it out. But they're also running a large monolithic application, which you are as well. How big of an app are we talking about for Basecamp?
So for the current version of Basecamp that's running in production, we call that internally BCX, which is basically Basecamp 2.
Hmm.
The application itself is about 25,000 lines of code.
Hmm.
So it's a pretty reasonably sized app, and it's very much a majestic monolith. I'm a big believer in monolithic software, in designing things as integrated systems, and Basecamp is proudly carrying that flag forward. We're currently working on a new version of Basecamp, as we call Basecamp 3, and it follows in the same footsteps of those majestic monoliths before us, and that's currently clocking in at around 18,000 lines of code.
Okay. And I'm going to ask you a few more questions about that as well in a little bit, just to know what kind of optimizations you've been able to do. Before we move on to that, can you describe a little bit of your architecture, like what kind of load balancers are you using, web servers, etc.?
Sure. So there's nothing really fancy going on. We have big IP load balancers in front, which are these big honking units that I think much of the industry is using once you get to this kind of scale. Then we use Nginx as our
Hmm.
main web servers. We use those for a variety of things, including fiddling things back and forth to the app servers. And for the app servers, we predominantly will run Unicorn, so
Okay.
just the single-threaded app servers. We're also in the new version of Basecamp working with Action Cable, which is this framework for dealing with WebSockets. And for that, we're running, I think, either Puma or Thin. I think we've been
Okay.
experimenting with both, but either will work fine. And then finally, for the database, we run MySQL as sort of the main system of record, and then we run Redis for a variety of optimizations and for things that do not necessarily need to survive a crash not system of record systems. And we also run Memcache for caching.
What's the decision behind running on your own hardware instead of using the cloud?
For us, it's mainly been one of cost.
Okay.
So we've, over the years, a couple of times just analyzed what kind of performance can we get out of buying and racking our own hardware, given the fact that we already have a substantive ops team.
Hmm.
So we have people already capable of doing this work. So that's not an additional sort of line item, which leads us to be able to compare the price simply on what it costs to buy servers, how much performance do we get for it against the cloud. And the last couple of times we've made these assessments, most recently we did one on storage where we compared the price of storing all our user uploaded files on AWS versus
Hmm.
Clever Safe and distributed. So we could do it cheaper by a factor of four or something like that. So it was a very substantial saving. And given the fact that we're not one of those VC-backed companies that are all about hyper growth, profits is actually something that matters. Every dollar we spend, I have this internal conversion mechanism in my mind that calculates exactly how much is going out of my personal pocket.
Uh-huh.
That's something I care about. That's something we care about. So even if it would be perhaps, I don't even know if it would be less hassle, but let's just assume that it would be less hassle to store things in the cloud. And certainly on some parameters, it would be less hassle. Like it's far easier to provision a new server on the cloud than it is to do that in hardware. We just had that discussion internally for Basecamp 3 where we were revisiting some of our original estimates and thinking, oh, well, maybe we need a little more hardware. And we were looking at like, oh, 2 weeks. Like that's actually impressively fast that we can go from 2 weeks from ordering a new server to having it all racked up and operational. But still, compare that to AWS and just clicking a button and say, hey, spin up another instance. That is obviously an eternity. But the fact is that we're in a pretty stable business, except for the very rare times where we launch a brand new version and we're uncertain about what load looks like. The vast, vast majority of time, we can predict exactly how much storage we need like 18 months in advance, just because the usage curves and adoption is just very predictable. Basecamp and the business that we run is a very predictable business. So when you have a very predictable business, when you care about profits, and as long as the economics of installing your own hardware pan out, I mean, it wasn't that hard of a call to make.
I'm really curious to see if any of this changes in the future as prices go down, as they have been. But even like you said, four
I'm
times
sure
is
it
a
will.
big difference. Yeah.
I'm absolutely sure it will. So over the very long term, I'm convinced that it will not make sense for us to run our own servers in the
Right.
very long term. But the fact is that the very long term can be a very long time away. And I have, I'd actually, I would have thought that we would have been there sooner. I would not have thought that the economics of running your own servers at our scale with our team would have made sense for as long as it has, and that continues to make sense.
Right.
Um, but there will be the day, I'm sure, where it does not make sense for us to carry these things around anymore. The economics of scale that something like AWS and other cloud providers can get, you'd think at some point that's just going to reach a tipping point where it just is not economical to do your own
Right.
installations.
Right.
But we aren't there yet. So I'd certainly encourage anyone who are at sort of, especially medium scale. I think that's really where the flip over is. At the initial stage, it doesn't make any sense at all to rack up your own servers. When you don't have large enough operations to have an operations team, it's far better just to rely on the cloud. Then there's sort of perhaps the wild growth state, if you are to be so lucky, where you can't predict what kind of resources you need 2 weeks from now. Cloud, perfect sense. Once you hit your stride of like, oh, we have a stable, predictable business here, it's medium scale. We don't need to build our own data centers, but at the same time, we can just rent some space somewhere and set that up, and then also have full control over the entire stack because we have a team to do it. I think it still makes sense. It
So
is an ever shrinking market of making sense, though, I think.
that's a good way to put it. So when thinking about MySQL and thinking about all that data that you have in there, I've tried to read a few of the articles of how you've been able to optimize that and scale it moving forward, and using things like InnoDB compression, that sort of thing. Can you share a few other optimization techniques that you've used to really, I don't know, either compress the data or make sure that it doesn't slow down? How do you do that?
I don't know if there's really that big of a bag of secret tricks that we run around with. A lot of it is just the fundamentals. Figuring out the right indexes is obviously a huge thing.
Right.
And one of the deceiving things, especially when you run MySQL on SSDs and very fast hardware, is that things can look fine, 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 fine. Oh shit, they're not fine at all. And those tipping points, those shit points, come when all of a sudden the indexes don't fit in
Right.
like whatever fast retrieval method that you were fitting in before, and then you have a bottleneck. Or that you start with something that works well when customers are querying data sets of hundreds, and then all of a sudden they're querying data sets of thousands or tens of thousands, and then doesn't scale anymore either. So a lot of that scaling technique had really been about observing the changes in the performance, paying a very close eye to the data sets that your customers are using. Once they hit certain tipping points, you got to do something. And oftentimes that got to do something is an application change. Like we have had pages in Basecamp that naively just loaded, let's say, all the users on a Basecamp account. Well, then some users or some accounts decided to have 5,000 users. All of a sudden, we were loading 5,000 users and trying to display them on a single page. Well, surprise, surprise, that didn't work well, right? Like it made everything tip over. But there's been in the past other aspects of it where we've relied on Percona and others to help us. But
Right.
I think that the part of just running this stable infrastructure. I mean, we've been using MySQL for over a decade, and we've been growing with it slowly and predictably. That most of these tricks of the trade have been just sort of stuff you pick up along the way when you do it. I wouldn't say that there's like, oh, a couple of secrets that we have that are really big. I'd say pay attention to your query times. Make sure you have a great way of tracing those requests. I think one of the areas where we really have leveled up is Noah, our data everything guy, has built a very nice system for us to query all of our logs, trace them back to requests, trace those all the way back to all the pieces of infrastructure that touches, and just made it incredibly easy for us to find the hotspots where they are and when we encounter them, and what to do about them. One thing is that you figure out, oh no, my database is slow. Well, that's interesting, but more interesting is why is it slow? What's causing it? Where's it coming from? And then figuring out how to fix those database call, optimize things at the right indexes, or cut down on your query load.
So you've built some of your own monitoring tools. I know you've used New Relic in the past. Are you still using New Relic or other monitoring tools, or is it mostly internal things?
It's 100% internal.
Oh,
It's
wow,
many
okay.
years ago since we've switched away from New Relic. I think that New Relic and Skylight and other tools of that nature, they sort of fit in the same discussion as should I use the cloud or not. When you're starting out, absolutely you should use those tools. It does not make sense for you at all. Unless you're a data monitoring company, why the hell are you spending time building data monitoring systems? Well,
Yeah.
it does make sense once you get to a certain scale. And I think that is where some of those tipping points are, that once you're building out your own systems, and you have teams to operate those systems and tailor them, it can absolutely make sense to build exactly what you need for your performance characteristics and your setups. I mean, a lot of apps are the same in a lot of ways at a low level of scale, and then there's a far more divergence once you get to a high level of scale. And some of the systems that we've looked at just don't really make sense at the loads that we've had, or they didn't give us the drill down that we needed, or they had other issues.
I had a really interesting talk with Simon of Shopify regarding performing failovers. So how do you failover from one data center to the other? And he mentioned the technique of using Nginx, where you have the user browser is spinning a little bit longer, you queue that request, and then you let it pass through. I know you guys have used that in the past as well and are probably still using that. Can you explain a little bit more of the process and how you perform these failovers?
Sure. So where we've mainly used it have been failing over the database. So in the bad old days, when we didn't have this setup, when we needed to do a major migration against the database, we would actually take Basecamp down. Like we would put a little notice in the app and say, "Hey, on Saturday night from sort of 8 in the morning to 9:30 in the morning, we're going to take the app down because we need to migrate the data," which is a very crude and intrusive way of evolving your system. So I think one of those big level ups that we've since had is figuring out how to pause requests in such a way that we can hot swap two different databases. So what we do is we have a primary database that is replicated to a replica. We make the change on the replica. Then we make sure that it's caught up with all the data changes from the primary, and then we basically make the replica the primary and the primary the replica, like we swap them around. And the tough part is what do you do like while that swapping is going on? And I think the tool we're using, which is actually something we built internally ourselves too, I think we call it transmission or something, allows us just to pause those requests for upwards of 10, 20, 30 seconds or something like that while the swap is going on, while that's being effectuated, and then sort of release it. It's more like a traffic cop, just say, "Hey, wait a second, let these guys pass," and once they passed, let them back in. For failing over between data centers, like that's a whole other kettle of fish, and it is very, very tough. Like I'm not gonna. I think we've spent through a variety of different approaches. We spent like 3 years getting to the point where we could do it.
Yeah.
I mean, it wasn't necessarily full speed ahead all those 3 years, but we tried a lot of different things, and it's tough. I'd say it's certainly not one of those things I would want to undertake in the early stages of life. Like it just sucks all the energy out of a lot of things, and it introduces a significant amount of operational complexity on top of everything. But once you get to our scale and our stature as a company, I look at it like a calamity insurance plan. Like the odds of our data center being wiped out entirely are very low, right? But if it happens, it's absolutely catastrophic. Like if for whatever reason we should happen to find a Basecamp offline for 3 days, 4 days, 5 days a week or something like that, that could be a total calamity for the company, right? Like nobody's going to sit around and wait for their product to come back after a week. And you might think in this day and age, oh, well, that sounds unrealistic, but we've had enough close calls. I remember there back in, I think maybe it was 2008 or something like that. A truck drove into the power station or something
No way.
the data center, Rackspace data center that we were in at the time, and the backup generators failed, and some people in that data center, we were lucky. I think we came back up after maybe 48 hours or something, which was traumatic enough in itself. But others were not so lucky, and it took, I think, close to a week. So once you've had that actual experience of seeing what happens when a truck drives into a generator and it takes a whole data center down, you go like, hey, wait a minute. I mean, if it could happen once, it could happen twice, and there are all sorts of other calamities that could happen. Are we willing to risk the business on that, even though it's a remote chance? And our conclusion was, no, we're not willing to risk the business on that.
That's a massive cost.
Let's buy an insurance policy. Let's buy a backup data center. And I mean, that's been a massive, massive undertaking. I think that actually operating multiple data centers, building systems to fail over between them and so forth has probably sucked up more than any other project we've ever done on the operational side of the business. So certainly not something to be taken lightly. And I think that is also one of the places where the cloud helps. that it is easier to distribute things. AWS has a scale that allows them to do some very clever things with failure migration. Even though, I mean, it's funny we say that, and then what was it, a week ago that like half the internet was
Yeah,
down because
on the East Coast, I think.
AWS
Yeah,
had an issue. So nothing is 100%. We're in the nine hunting game, as I like to call it. Like I think we're at like 4 nines right now on the main version of Basecamp, 99.997 or something on uptime. Very proud of that fact. The team has done a fantastic job doing that, but it does not come without a lot of blood, sweat, and tears. And I'd say that level of reliability is absolutely not necessary in the beginning. I remember when we first started with Basecamp, like we had like 99% uptime, which sounds high, but if you actually calculate that over the course of a year, it's
right,
not that high. It means like
right.
we're still down for days in aggregate. But in the beginning, I think that that's totally fine until you figure out that whatever you're building is the thing. It makes no sense to make it uber resilient unless perhaps you're in some special environment where like that is the main thing that you're selling. But I think for most application, that's not the case, and that time can be better spent just figuring out, hey, is this actually the right app? Is this the right thing? Do people want to buy it? Do they want to buy it in bulk? Are there lots of these people, and so forth? So it's one of those things where for us, we've been getting gradually more sophisticated, in part because we can, and in part because that's just what you do as time goes on. But it's easy for someone starting out to hear these stories and think, oh no, then I need to do all this stuff and I need to be able to fail over between multiple data centers and I need to blah, 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 blah. No, you don't. Like the worst thing in the world that most companies starting out can do is listen too much to companies who've been around for a very long time because they just face different challenges and there are different life stages. And we always say this as on organizational issues that what do you think you can actually learn from Jack Welch? Like running a company of 100,000 plus, it's just a completely opposite problem from running a company of 20 people. So oftentimes I'd say the same applies to scaling techniques. The lessons that say a Twitter takes away from the fact that they're have 300 million people who manically update their timeline all the time and send this stuff out for 10, 20, 30 million people. Like it's a different problem. Like the trade-offs you face at that scale are in many cases in direct opposition to the trade-offs that you should be making
Right.
in the early days of the business. And I think a lot of it comes from the fallacy of thinking you could get it right the first time anyway. There's no system ever in the history of mankind. I'm making wild fucking proclamations here, but that have from day one, from the initial implementation, just been able to scale up until what we like to call web scale today, this hyper scale where like a good proportion of the world's population is using the system. It just doesn't,
Right.
it very, very, very rarely, if ever, happens that way. The vast majority of the time, even when you intend it to be so, you figure out along the way, oh, either you built the wrong system that users didn't like, or that the scaling issues are actually in other parts of the system. So optimize for the stage that you're currently in. The early days, it is not about having multiple reliability or absolute scale. It's about figuring out, making something the users want.
And I would say another thing that is very useful in probably all, if not most of the different stages is having speed, having a really fast application.
Yes.
So your users are not waiting. So let's talk more about that. And as you said, Basecamp 3 is coming out. You've done some amazing optimizations on the current Basecamp, but what other kinds of optimizations have you been able to do since you've built Basecamp 3?
So Basecamp 3 is in many ways a continuation of the techniques that we explored in Basecamp 2. And one of the most important is this notion of Russian doll caching,
Yeah.
where you cache in depth, where each sort of partial, as we call it in Rails parlor, each little segment of the page is cached individually, and then you're building larger and larger and larger caches. And the reason you do that is such that whenever you have cache invalidation, say you have a message page that has 100 comments on it, right? Like somebody changes that one comment. Well, that needs to obviously invalidate that comment, and then it needs to evaluate the overall page that contains all those comments,
Right.
but it does not need to invalidate all the other 99 comments. So having these caches at separate levels such that invalidating one thing just means that that one aspect of the page needs to be rebuilt, and you can still reuse the other 99 bits is huge. It imposes some important restrictions on the way you design your templates and the way you design your UI. Obviously, the more people use the same cache, the better off you are. So you can't do things that are tailored within the individual caches once they're written to the cache that are user specific. You can't say, "Hey George," in like if George is the this current username, right? Like you have to replace that with placeholders that you then replace with JavaScript or something else. But once you've become accustomed to using this Russian doll approach, you can really make exceptionally fast pages, even though that they're very expensive to calculate from scratch. So that's usually the trick, right? Like people you look at a page and it has like some of the pages we have in Basecamp 3 now, if you calculate that one from scratch, it's just going to generate maybe even hundreds of SQL queries. Like there's no way that's going to be fast. Even if we used a very fast programming language, we could certainly make it faster, but it's even better to not do that work at all. And the best way to not do that work at all is to do the caching. So on top of that, one of the things I think the trap a lot of web developers fall into is that they tend to care about the things that are easiest to measure. And the things that are easiest to measure is what's happening on the back end, how fast the server responds with a reply. Oh, am I doing 100 milliseconds? Am I doing 50 milliseconds? Am I doing 200 milliseconds? They sort of care about things within a sort of tight range, which is appropriate. Like if you can't make your server respond in 200, 300 milliseconds, I mean, you should look at that stuff and figure it out. And usually the answer is caching. But once you've arrived at that, it does really make a whole lot of sense to be overly concerned about whether you go from 100 milliseconds to 70 milliseconds. Because you know what? If you're looking at the whole user experience of loading that page, it's probably going to take more than a second. And you go, wait, what? My server responded in 100 milliseconds. How can this whole thing take more than a second? Well, because you have all the other things that go into a web application. You're loading tons of assets. Are you loading images of the right size? Are they compressed in the right way? How many of them are you loading? How is your CSS structured? Are you using terribly slow selectors? How is your JavaScript set up? Are you deferring the evaluation of your JavaScript until the latest possible moment? What are you doing to display things as soon as the browser starts parsing the HTML? There are all these concerns that are on the table when you take a holistic view of things and say, like, I don't actually care about how fast one individual component of the system is. I care about how fast the whole system is and how fast it feels to an individual user. And I think that that's one of the areas that we've really focused a lot on in Basecamp 3, especially because we're getting even more ambitious on the mobile side of things. And we're using web views, as we call them. Parts of the real application are loaded inside of native applications, and that has to feel really fast for the native application to feel as though it's on par with other applications that are completely native. So a lot of attention and effort went into cutting down on our JavaScript, right? We actually just recently did a project where Javan, one of our JavaScript focused developers, cut down our whole bundle in half. So we went from like 500 kilobytes compressed or something to 250. And it made a very measurable difference in the performance and the perceived performance of the page. And a lot of that just go through all the jQuery plugins. That's usually where it is. And jQuery plugins get a lot of hate, but I don't think that's appropriate. It's simply because they're trying to solve a lot of problems. And when you take something like jQuery UI, which is a huge honking beast, and you use it to do what? Like just some drag and drop or a few other bits and bobs here and there, like you're taking a very heavy piece of machinery and you're using it for one specialized purpose. Well, that's probably not going to be the fastest thing that it could be, right? So we took a bunch of these generic honking mega plugins and then we just plucked out the few bits and pieces of functionality that we needed and we rewrote it accordingly.
At what point do you think it makes sense to do that kind of optimization?
Very late in the game, as late as you possibly can. That's why I love jQuery plugins. I love plugins of all kinds, is because they provide you with a level of scaffolding that very quickly lets you test out an idea. There is absolutely no sense in optimizing that which is not going to be used. And developers have a habit of falling into this trap over and over again, right? Like they're doing some implementation of a new feature and they just get sucked into optimizing it too early, and then the designers or the owners or wherever directing the work say, we don't need that feature anymore. You go like, what? I just spent 2 effing days optimizing this shit, and now you're telling me we don't need it at all? That's the best way to fall in love with your code, is to just spend endless time
Right.
polishing and optimizing it, and then you become defensive and you don't want to let go of it, and you end up with a worse application because of it. So the later you can possibly optimize, the better off you are. Now, that needs to be said with some grain of salt. There are certain tracks and certain paths you can follow where you can end up so far in a hole that there's just not going to be time enough to dig yourself out of it. So you gotta have an eye on it, but not be sort of paranoid and overly focused on it. And I don't know if there's a better description of that than it's just something you learn in time. You get
Right.
burned enough times over optimizing something that then gets thrown away, and then you learn, okay, maybe let me just set things up in such a way that I know that there's a path to optimizing this. I don't have to do the optimization right now, but I know that there's a path.
Mhm.
And that's really been, I think, perhaps one of the most important aspects of the architectural discussions and concerns we've had around Basecamp 3 and any other application that we make, is to sort of just to have enough experience and enough insight to know that there's a path.
Mhm.
App doesn't need to be fast right now. It can even be kind of slow, but you know which routes to take to make it fast, and they seem credible. Sometimes credible routes turn out to be dead ends anyway, and you go like, oh shit, again. But most of the time, with some experience, they're not. And then you end up not wasting your time over optimizing something up front, if it's not needed in the end. I'd say then finally, the aspect that's made Basecamp 3 in particular seem so fast, which is the use of WebSockets. So Basecamp 2 and earlier versions of Basecamp used a variety of polling mechanisms and Ajax updates and so on, that weren't using WebSockets. Well, WebSockets are really fast. I mean, probably shouldn't come as a surprise to anyone, but the reason it is so fast is in part because it's a persistent connection.
Mhm.
So a lot of the overhead and slowdown when you're interacting with a web application is not necessarily from the work it has to do, but the fact that it has to create a new SSL connection every time.
Right.
Sometimes you get to reuse that SSL connection, and sometimes you don't. It's a very sort of opaque machine to look into to realize, like, why did that SSL handshake just get evicted? Why do I have to handshake again? And there's a lot of operations that we have, where that is the majority time spent, especially from someone who's further away from our data center than the US, right? So if you're
Mhm.
sitting in Europe and trying to use Basecamp, the vast majority, I wouldn't say the vast majority. Sometimes the biggest perceived slowdown, if you look at the web inspector, is actually the handshake time, right?
Yeah.
You
Yeah.
can spend 500 milliseconds doing the SSL handshake, and then you spend like 100 milliseconds getting the update that you need. And you
Yeah.
go,
It's frustrating sometimes.
it's not proportionate, right? That doesn't seem right. Well, the cool thing about WebSockets is that you make that connection once.
Mhm.
So you pay for the handshake one time, and then all the data that goes back and forth across the wire is already encrypted. It's already good to go. So
Mhm.
it makes a big difference in the perceived performance. So we embraced WebSockets in a big way. Rails 5 is going to ship with a whole framework dedicated to working with WebSockets, Action Cable. And this Action Cable we've then used in a bunch of the UI elements of how to load things dynamically and how to get updates and so forth. And um, that's been a really nice benefit. But still, it's something that you layer on. It's something that deals with certain amounts of edge cases. The vast majority of our app is still traditional, quote unquote, in the sense that we're generating HTML on the server side and then we're sending it down. Now, the other aspects of it that bears mentioning is TurboLinks. So TurboLinks is this framework that we uh, evolved from the early stages of what was called PJAX and other techniques
Right.
back in, well, not back in the day. Some people still using PJAX, but it evolved from that. And basically, what it does is that it kind of tries to set up that persistent connection again, right? So just like WebSockets deal with the SSL handshake once, TurboLinks sets up a single process that deals with the evaluation of JavaScript and styles once. So it's kind of like a persistent process. I like to think that when you're not using that, it's kind of like using CGI, that you build up the
Mhm.
entire machine that needs to reply to this response one time on the server side, and then you throw the whole damn thing away. That's a very inefficient way to do things. And that's part of the reason why single page JavaScript applications have been so fast in comparison to traditional web apps that weren't using this technique, because they set up this persistent process. Back in the day, we called it, there was CGI and then there was fast CGI. And fast CGI and any other persistent process basically relies on the fact that you compile your system once and then you keep that instance around and it can respond to multiple requests, right? So TurboLinks does the same thing on the client side. It sets up a persistent process once where it evaluates the JavaScript and the CSS one time, and then any subsequent updates from there can happen within that persistent process. Well, surprise, surprise, if your app, even an app as tightly optimized as ours, where we only have 250K of compressed JavaScript and I think we have maybe 300K of CSS, if you have to evaluate that and fetch it, even against the cache, every single page turn, that's going to feel slow. It just is. So TurboLinks takes care of that problem, and I mean that is even more important than like the web sockets work and so on we've done. TurboLinks makes it such that you, in the vast majority of cases, can't tell the difference between whether this entire app was programmed in JavaScript or just a transport layer was, which is a much nicer, in my opinion, development experience, because I think the development experience of working with server-generated HTML is just wonderful and far better than what it is to try to create a thing with client-sided JavaScript.
I want to ask you about server-generated JavaScript responses, actually. But first, David, I want to tell you about Rollbar. You and Ruby developers, or really any developer, since Rollbar works with every language, I highly, highly recommend that you take a moment to go to try.rollbar.com/SYC to set up a free account. If you ever run into errors, which 100% of you do, then you should try Rollbar. If your users run into errors in production, which happens all the time, then you should also try Rollbar. Basically, if you're a developer and you're not tracking errors for your development team or development process or production, then you should really try Rollbar. I use it at Scale Your Code. I can't recommend it enough. It's a fantastic product. Go to try.rollbar.com/SYC. That way they'll know that you came from this show and they'll treat you really well. Try.rollbar.com/SYC. All right, David, so going back to SJR, you wrote a post about it in late 2013, and it really got a lot of attention and caused a bit of debate. I've got a question from the community username DJS Laker from Reddit that asks, what are your thoughts on the shift to thicker JavaScript clients on the front end served up by REST APIs, and how does Rails plan to evolve into that model versus rendering view logic predominantly on the server side? What do you think about that?
I'm trying to figure out a way to phrase things in a nice conciliatory tone, because I think a lot of the debate over this have been needlessly hot, loud.
Yes,
and a lot of that comes from the fact that people think that this is a clash of civilizations, that there can only be one idea that prevails. And that's just bullshit, as it always is. Well, so first of all, I'd start by saying that generating HTML and any kind of view response on the server side is not only completely legitimate, it is my absolutely preferred way of creating web applications, including brand new ones that are being made today. This is not a relic of history in my mind at all. We're creating brand new large applications today following these principles. Now, that doesn't mean that doing client-side MVC is a bad thing. We use some client-side MVC principles in a variety of the aspect, even of our latest application. For example, we built something called Tricks, which is a brand new what you see is what you get editor. It's completely client-side JavaScript, like the entire state and controllers and models and so on. It all lives in JavaScript, all lives on the client side. Wonderful use of that setup, right? Like you would certainly not want to communicate with the server every single time you typed a key and we're figuring out whether that should be italicized or bold or whatever. So there are a lot of, it's a spectrum. And I like to use the spectrum where I get the most traction and the most torque and the most productivity out of things.
Right.
And what I find is doing everything as a client-side JavaScript app. When you talk about applications that are like Basecamp, like Shopify, like GitHub, like those kinds of applications, they don't win by moving all the logic and generation of the view to the client side. They don't win at all. They become, in my opinion, more fragile and worse off. So that doesn't mean there aren't other domains. I think Skylight, what Yehuda and company are doing, the way that they interact with sort of heavy visualizations and forms and so on, much better fit for it, much closer to like what a text processor like we're building in Trix is like. So things can make sense there. I think there are other examples though that fall in the camp where I sure as hell wouldn't have used client-side JavaScript for that. And those are perhaps more numerous for me than they are for other people. I certainly still see the world of web development as the types of application that I see, the types of application that I use, the types of application that I think most people are interested in building. I still see the vast majority of those falling into a camp where they're better off creating HTML and server-side and then sprinkling. It's funny, I love sprinkles. JavaScript sprinkles, which is this term of like you send HTML from the server side and then you sprinkle some dynamic elements into it through JavaScript, right? The people who are staunch believers in client-side JavaScript, they see sprinkles as something negative, right? Like that's derogatory terms. I see it as something wonderful. I couldn't imagine something better than sprinkles. Like, who doesn't love sprinkles? So we sprinkle JavaScript over those server-side generated bits of HTML, and it works wonderful. And we do SJR2, where we at times respond with so say you're making an AJAX call from the client side, like delete this comment, right? So you click the delete link. What should the server side do? Well, the server side could just respond with a HTTP status code saying, oh, yep, okay, it was done. And then on the client side, you can have some logic to make that disappear. Or you can just put that logic on a JavaScript response from the server that says, make this one disappear. I think the latter is fine. Not only is the latter fine, the latter becomes far preferable when you're not just responding saying, hey, remove this DOM ID from the tree. It's super powerful when it comes to add this bit of HTML using the same template that I used to generate the page in the first place to the DOM, right? So for example, you're rendering a message that has a bunch of comments. You're rendering those comments on the server side. Now you want to add a new comment to that page. Well, you could do that client side, right? Which would mean re-implementing the template that displays that comment again, if you were sort of doing it where you still had HTML on the server side. So you'd do that, and then now you'd have two templates, right? Or you set things up in a way where it has to be a fully client-side application where what you're getting from the server is just a JSON dump, right? And then you have to generate everything on the client side. I've not found that to be a good time either. So, yes, I kind of got dragged into the rabbit hole here. What was the whether things still made sense in going forward? Yeah. So what I want to say on that topic too is that for Rails, and especially for Rails 5, we can have our cake and eat it too. Rails is a very large tent and a very large framework. It's trying to do a lot of things. It's trying to basically be a one-stop shop for creating
right, absolutely.
the majority of web applications today, right? We don't have to have everyone use all elements of the app. And what Rails 5 is doing is building in a specific mode called the -- API mode, where when you generate a new application and you say -- API, you're going to get a skeleton that's targeted at generating just JSON on the server side, not any view logic at all, not even using the asset pipeline, where you basically build a distributed system from the get-go, where the server is simply responsible for integrity checking and access control and all that other logic you have to deal with the model, which is actually in most applications a bunch of the logic, right? And then it just returns JSON. It's an API server. And then you build separately a view component that's a client-side JavaScript app, and you build maybe other apps. You build a native application and other consumers of this app. Well, that's taking out a pretty small majority, actually, or minority of the Rails code base and saying, okay, that bit I'm not going to use. Well, people do this all the time already. Like there's plenty of people who say, well, I don't in this app I don't need to talk to a relational database, so I'm not going to use Active Record. Or in this app I'm not going to do this, I'm not going to do that. I take bits and pieces out. Well, with the API approach, that's the same thing. You just say, oh, I don't want to use Rails to generate HTML on the server side. Hey, we could still be friends. No, no skin off my back. Let's work together on the things where we do share elements. Let's work together on making Active Record even better. Let's work on improving Active Support, or maybe you want to use Action Mailer or any of the other many frameworks that we have in the Rails bundle. We can still share those and use them together. So that is to say that even if you are in the camp where, oh, the future is all client-side JavaScript, hey, more power to you. Make some awesome apps and delight some users, and we can still share Rails, and it'll be good for you.
Mm-hmm. So I think the lesson here is, instead of calling out and saying, oh, you did it wrong, it's not going to work, being patient and see if it does work or not. If it works for you guys, then what's the problem in that?
Yeah, I, at least at a macro level. On a more micro level and more detailed level, I'm perfectly comfortable, at least personally, rendering all sorts of verdicts on how people approach things. Because I look at an application and I go like, yikes. Like, certainly not how I would approach it. And I just look at that, looks like just a needless amount of work to get there. And the path that you're taking is not the path that I would have taken. But I think the maturity of a large community like Rails is that we can say, hey, we can disagree and we can still be friends. Not only can we still be friends, we can still work together on a wide variety of things, even though I think that the ultimate path that you're picking is not one I would have picked, and I might even be louder than that, but it doesn't matter. I mean, we don't all have to agree on all the things all the time to make progress together.
Mm-hmm. So I've got quite a few questions left, but unfortunately we're not going to have time to go through them. So I'm going to narrow this down to our last two questions, because I'm really interested in what you're going to say about this. You were under a DDoS attack back in March of last year. What did you learn about this attack, and what advice can you give to other people that may run into these attacks in the future?
Well, first, that it sucks, and it sucks hard, because a DDoS attack of a sizable magnitude is one of those things that's actually pretty hard to 100% shield yourself against. There's a variety of hardware bits and bobs that you can buy that kind of try to do some of the mitigation, but the only real mitigation that kind of works on a general level is to have more bandwidth than your attackers do.
Right.
So if you have 40 megabits of bandwidth to your app and you're being attacked by 200, it's pretty tough. Well, what makes it a little easier, at least, is if you have good relationships with your upstream providers. I've heard some bad horror stories from people who just couldn't get their upstream providers to help them at all, and then they're stuck here and they're just being bombarded and they can't do anything about it. After we were attacked, we started a DDoS survivors group with the operations team and operation teams of other companies that have been attacked as well. And we heard some just heartbreaking stories of people, especially at smaller companies, that just didn't have the cloth to affect their upstream providers at all, or even know who they were, and didn't have ops teams to deal with it. They were just down for a week, and you just go like, wow. Oh shit! I mean, you're down for a week. That's horrible. I mean, we were down for, I think, just under 2 hours. And
are these usually to extort money, right? To say, hey, I'll stop if you pay me? Is that the kind of attacks?
Sometimes. That was at least the cover in our case, that we got a shakedown letter for, hey, you got to wire so and so many bitcoins to this and this address. But a lot of times, too, it actually comes from a variety of actors who are attacking sites who are hosting something on behalf of other people that they don't want out there.
Right.
So if you're a GitHub or you're any publishing platform and somebody uses your systems to put up some code or some writings or expressions of any kind that someone else don't like and they want to see them off the internet, well, that's the sucky part, right? Like, you're a service provider and you're being pulled into this fight, but that's how it goes. So I think one of the reasons that the Basecamp have been shielded from this for a long time, I mean, people have been dealing with DDoS attacks for a very long time. This was our first, was that we don't actually have any public data. So we're not a good target for somebody who's just like, oh, I don't think like that is such and such.
That doesn't make sense, yeah.
That doesn't make sense to attack us for that, but it did make sense, at least for this person, to attack for trying to shake us down. But
Sure.
our conviction from the get-go was we're never going to pay anything.
All right, last question. Let's wrap up with this one. What do you look for when hiring?
Yeah, that's a good broad question. I look for great software writers. That's the at least when I'm hiring for a software writer position. And how do you actually figure that out? Well, there's a bunch of indicators that you could use. You could try to think, oh, did they go for an Ivy League education? Did they work at a prestigious firm? Did they do all these other things? And I found that those indicators are not very helpful at all. And not only do they produce duds, but they produce tons of false negatives. That many of the very best programmers in the world are autodidacts, that they learn programming themselves, not through any accredited school. They just figured that out and got good, right? So how do you get those people into your sites if all you're looking for these secondary concerns? Well, for us, it's been a lot about looking at the code. I mean, I'd say that a lot of programmers just self-select themselves out of the pool. We for any programming job, we get maybe somewhere between 100 and 150 applications.
Okay.
I'd say that a good 80 to 90 of, well, at least 80% of those are rejected outright because people just spam us with a resume. Like, hey,
Right.
places I've worked, and this is the year I graduated. And I go like, what the fuck? Like, how's this actionable information? Like, what am I going to use that for? I think resumes in a general sense are pretty worthless when they come to assessing the capabilities of programmers. So I pay very little attention to them. They're heavily discounted, let's put it like that. And then the other fact is that then they write a cover letter that's just generic, right? I get where that all comes from. Like maybe you've had a couple of rejections and you don't want to put a bunch of time into making one application. Well, I think that's sort of a self-fulfilling prophecy, right? Like sending out a bunch of applications that are just your resume and a generic cover letter. I don't know how many people are going to get excited about that. I certainly wasn't, right? And we were lucky enough that even if 80% of the applications we get fail that test, that still leaves 20% that pass it. So from the 20% that passes, which is basically people who write us a good cover letter that demonstrates some knowledge and interest in our specific company and organization and tools that
Right,
we're
okay.
using. They make it through the first pass, right? But after that, I try to look at code. I found that I very quickly can form an opinion if I see a substantial body of work from someone on their skill set. Some of the things are rudimentary in terms of how do you care about the presentation of your code. I'm not a stickler for like, oh, you made a comma error or you made a spelling error in your cover letter and that immediately puts you out of the pool. Of course it doesn't. That's completely foolish. I fucking make spelling mistakes all day long. Tweets that go out to 140,000 people, right? So I'm not going to put myself on a pedestal here, but there is a point where there's a tipping point where it establishes a pattern. Like this person is just not diligent enough with the quality of the code that this is something that fits what we're looking for.
Sure.
And a lot of people fail that test. A lot of the code is just like poorly indented, poorly named, poorly
Really?
scoped. I mean, it sort of ratchets us up from there, right? Like some of the code, if it's already poorly indented and like it's full of things that are commented out or whatever, you just go like, really? Like, if
Are you looking
find
at things
guess-
on GitHub, for example, like just out of random? Okay.
Not random. People usually submit this. This
Oh,
is
wow.
what gets me too, right?
No
That
way.
Somebody would submit a piece of code and like they just wouldn't clean it up. It's kind of like you're inviting your prospective employer over to your house and you didn't fucking even clean up. Like there's
Right.
just
That's weird.
last night and like all sorts of crap all over the floor and you just go like, okay, I mean, it doesn't mean you're a bad person. It just means like put some fucking diligence into this stuff, right? Like you don't have to impress me like it's the Pope coming over for dinner, but could at least just do a minimum to clean up the mess. So there's that, but then it's even beyond that because there's also plenty of applications that like they are clean and they are well prepared. They're just not that great code. And that is the unfortunate thing where a lot of people then unsatisfied with that assessment, right? Like, what do you mean bad code? Can you tell me exactly what you mean? It's kind of like sending somebody an essay, right? Like a short story, and like you just go like, I didn't really like that story, and they go like, what do you mean? Point to the line, the paragraph that's bad, fix it, and you just go like, yeah, well, I mean, I can't teach you how to write a short story that's interesting in like an email. I can't teach you how to be a good programmer in a reply to your job application. It just and it's a shitty response in some ways, right? Because how is it actionable just to tell somebody like, "Hey, your code is not that good," um, but that's usually just the underlying fact, and some of it is just I think at this point, at least in my perception of things, is sort of base level stuff, like that your methods are just not composed, like they're 15 lines long and they do five different things and like tons of local variables and all sorts of other setups where you just go like, yeah, I don't know. So I think to avoid falling into that trap, at one point I wrote up a blog post like so the 5 books that influenced me the most, and one of those books that I find particularly pertinent to this. Like, if you could just sort of try to internalize the lessons of small talk best practices, those are a lot of sort of the base level. It's kind of like on writing well for programming, which is this book by William Sincer, I think is his name, about writing well in prose. Well, small talk best practices, for me at least, is that kind of book for programming.
Okay.
It's very nitty gritty. It goes into just all the elements of proper naming, proper composition, and so forth. And if you've read that and practiced that, I think you're gonna take a big step forward in your career, and have a much higher chance of if you apply at a place like Basecamp to get to a point where I think like, oh wow, this is interesting. I want to see more. I want to learn more. I want to know some more. Well, for us then the final step is if you make it through that, we have to make you write some code for us. So the only way you can sort of sidestep that is if you already have a big body of work in the open source community. Like we've hired a number of people straight out of the Rails core group or otherwise associated with Rails because I had already been working on them or with them for a bunch of time on real code. If that's not the case, and that's certainly no disqualifier, you don't have to have open source contributions at all to work at a place like Basecamp. But I do have to work with you on code. So if that doesn't come through the open source world, then we sometimes do this where we do a test. So we pay someone to basically do a side project for us. And they can work nights or weekends or whatever. We pay them for the time to do it. It's not a big project, but it just gets us to sit down and work that out. And once you go through that process with a couple of candidates, it's usually very clear who you want to hire.
You get to see how they work and the thought process behind it.
See how they think, see how they solve projects, see how they write code when it's them faced with a new situation.
Sure, instead of having them write on a whiteboard on the spot or something like that.
Yeah, that is the worst thing ever.
Yeah.
I've railed against this frequently, and you can't rail against it frequently enough. Artificial coding sessions at the whiteboards are the devil, and companies that follow them deserve the kind of candidates that they get. It's just a terrible, terrible way of subjecting people to an extremely stressful situation, an unnatural situation where they don't have their workspace, they don't have their tools, and like if you pulled me out and made me write bubble sort or something on the whiteboard, like I'd probably fail that miserably. And I just think about like, hey, I would fail the majority of these right at a whiteboard tests. So to think that I can get something good out of using those tricks and techniques is just fully folly.
Well, I think this is a great note to end on, David. I really, really appreciate your time and your knowledge. I feel like this is a really good interview. How do you feel about it?
It's great. I always love talking about the specifics and the principles that we follow, and hopefully something can take something away from it.
Awesome. If people want to follow up with you, I know you're on Twitter at DHH. You also have a personal website, HeinemeyerHansen.com. That's with 2 S's. For some reason, I see a lot of people misspelling it, but 2 S's, right?
2 S's, but that's not even the main thing that'll trip you up. It's the Heinemeier part that I guarantee you will not be able to spell. So better look for that in the show notes or somewhere else where you can click a link. But at DHH, there's links to everything else from there.
Sounds good. Thanks again, David. Leave a comment. Let us know what you learned from this episode. And thank David for his time. Y'all have a great day.